So Faith is our next speaker, and Shanna and I both saw this talk and thought it was awesome, and that's why it had to be in here, not any, it was a fantastic talk. Let me find the, here we go. So Faith is a security researcher at LTAM and a cybersecurity undergraduate at Curtin. His interests lie in low-level software exploitation and vulnerability research. And what he's going to do today is talk to us about vulnerability research as a lifestyle. So Faith, it's all yours. We'll just give him a second to get everything set up.
Yep, sorry, okay.
No, that's okay, mate. Go for it.
You guys can see it, right? Yeah. Okay, so hey guys, so this is going to be vulnerability research as a lifestyle. I'm essentially going to try to talk about how you can integrate vulnerability research into your life, I guess, no matter what sort of security role you play in the industry or non-security role. That, as long as it's like computing related, which I'm assuming everyone that's watching is going to have a computing related role in the industry. So yeah, so a little bit about myself. I guess Ian already covered it. I am a cybersecurity undergraduate at Curtin, a security researcher at LTAM, and I mostly focus on low-level vulnerability research. So that involves like sort of targets like browsers, operating system kernels, hypervisors, things like that. So yeah, you may have seen that like picture of the plant on the green background, sort of like on Discord or Slack channels. So yeah, that's me. I go by Faith. So yeah, I guess I'll dive right into it. So what do I mean when I say vulnerability research, right? So vulnerability research is essentially the act of studying and analyzing the internals of some specific software with the aim of finding vulnerabilities, right? And this can involve a lot of different things, but more importantly, vulnerability research is a subset of security research, right? So security research can mean a lot of things, right? So there's vulnerability research, obviously. There's also research like, say, someone that tries to figure out how you can improve existing intrusion detection / prevention systems, how to create better cryptographic algorithms, more secure ones, for example. So security research as a whole is a very wide field or category, I guess, and vulnerability research is just a subset of it. So yeah, vulnerability research essentially involves things like code auditing / review. So that just means reading code, attempting to look for vulnerable or buggy code patterns or bug clauses in the code. In the instance that you don't have any code to review, you have reverse engineering, which involves using tools such as IDA Pro or Ghidra or Binary Ninja, things of that nature, to reverse engineer and disassemble and decompile code to read the decompilation or disassembly to find vulnerabilities. You also have what's known as automated static analysis, and that just means automated scanning tools. So things like, I know Silvio Cesare loves this tool. It's called Coccineal. You essentially give it a pattern, sort of like a buggy code pattern. You define it in this unique language that Coccineal has, and you just let Coccineal run on some code base, and it attempts to find all code that matches that pattern. So that's essentially what automated static analysis means. And last but not least, fuzzing is where you create just random test cases or random input for a piece of software, and you just run it through whatever software you're testing. And if the software ends up crashing, well, then you know that something's wrong, and you try to figure out if the crash can be exploited, right? So those are usually the 4 different things that you do when doing vulnerability research. So next question is, why would you bother with vulnerability research in the first place, right? So I think what brings all of us together is the hacker mindset, as people call it, right? So the hacker mindset is where you attempt to think outside the box. You always attempt to solve problems, always attempt to keep on learning as much as you can, right? And although anything you do in cybersecurity ends up with you having that hacker mindset, right? It doesn't matter what your role is. You can be a penetration tester, you can be a SOC analyst, you can be an incident responder. It doesn't matter. Whatever you do, the hacker mindset is always at play, right? But in my opinion, personal opinion, I believe vulnerability research is the field where the hacker mindset shows itself the most, because at the end of the day, you're trying to make the software do something that it shouldn't, I guess, in a way. So yeah, I believe it helps you improve the hacker mindset. It strengthens it to the point where you get better as a hacker in general, at like just period, right? So it's also something about, like say the software that you use every day, right, in your daily life, just like trying to figure out if there's a vulnerability in, say, Microsoft Excel or Adobe Acrobat Reader. Like there's just things you use every day. It's just that sort of like the curiosity that I believe the vulnerability research develops more, I guess. Another reason would be that it is very intellectually challenging. You usually don't have any knowledge about the thing you're doing research into at the beginning. So you have to really try really hard to do the research, to figure out what you need to know to actually find the vulnerabilities in the first place, analyze the internals of whatever software you're testing, et cetera, right? So that the intellectually challenging part is, I guess, what I enjoy the most, right? It's like you run into a problem and you can spend the next 48 hours on this one problem, just trying to figure out, how do I solve this? What's the solution here? And that's like, when you figure it out at the end, you feel like that those 48 hours was like, it was time well spent, right? Because you finally figured it out. Another reason, I guess this might be the biggest reason, is there's a lot of money involved, and I'll get into this in a little bit, like later on in the talk. So I'll just skip this for now, but there is a lot of money involved in vulnerability research as a whole. And finally, it's fun, right? You're breaking software. That's what we're all here for. Attempting to make software do what it's not supposed to is always fun. Like imagine, just as an example, you find a vulnerability in Adobe Acrobat Reader. You make an exploit, which is just a PDF file. You open the PDF file in Reader, and all of a sudden a calculator pops open. Like that's just, it's amazing, right? It's just one file and it just pops calc. Like, wow, okay. So that's why I think you should bother with vulnerability research. Now, how do you get started, right? And this is a very tough question to answer. There are many pathways into vulnerability research, but I'm going to personally talk about the way I got into it. This is not a predefined, like, set in stone way. I think there's multiple ways to do it, right? So I'll just explain what I did. So I started with CTFs, right? So this was like early 2019, last year. I just randomly decided, hey, I'll just, let's see what capture the flag competitions are all about. I read about them a little bit, never really tried to get into them. So yeah, CTFs have like multiple categories of challenges. They can be crypto, binary exploitation, reverse engineering, web exploitation, just random like categories, right? And I've always heard that CTFs aren't realistic, right? And this is sort of true when it comes to easier CTFs. So that's CTFs like Pico CTF, or just your like run-of-the-mill CTF that run on the weekends. And these CTFs are meant for beginners, and that's why they're not realistic, because if you try to teach beginners realistic techniques, they won't get it. So you have to start from the bottom up, and that's why these CTFs aren't realistic. On the flip side, though, harder CTFs are very realistic, and these are CTFs like, say, Real World CTF, or Google CTF, Facebook CTF as well. There's DEF CON CTF, which is very well known. And these CTFs usually have real world software as challenges, right? So real world software with vulnerabilities in them, such as browsers or hypervisors, or even operating system kernels. I remember real world CTF last year had a blockchain Ethereum exploitation challenge. That was really cool. Live Overflow did a video on that as well. So if you haven't seen it, you should definitely go check it out. It's pretty cool. So yeah, the main reason I recommend CTFs is because they teach you how to learn, right? And this is very important, I feel, because in this field, you'll always face new targets. And these new targets are targets that you won't have any prior knowledge about, and you will need to figure it all out yourself. And when I say by yourself, I mean, using Google, using existing resources, things of that nature. And the only way to get better at knowing how to do that is to do it more, right? And I believe that's how CTFs help you get better. They sort of throw you into the deep end of a challenge. They tell you, here's a binary, or here's a web address of a web application, and you have to exploit it and get a flag, right? And this mostly applies to harder CTFs, not the easier ones. So yeah, it's just, when you get thrown into that deep end, you have the time constraints of like 24 or 48 hours, depending on how long the CTF runs. You have to try your best to figure it out within that time frame and solve it and get the flag. Yeah, I believe learning how to learn is a very important thing in this instance. Yeah, another thing that CTFs teach you would be about bug classes, right? So bug classes such as in web applications, for example, you have cross-site scripting, server-side request forgery, cross-site request forgery, things of that nature. Or in low-level software, you have things like buffer overflows, integer overflows, use after freeze, things of that nature. CTFs really teach you how to spot these patterns in code, or in the case of disassembling or decompiling software, it also teaches you reverse engineering in a way. So this is very important to learn for later on when you go into the real world. But at the end of the day, CTFs, since they're time constrained, right, they don't give you challenges that might require you to spend over, say, a week or 2 weeks to figure out, right? And this is what I want to focus on a little bit, is that CTFs focus more on the exploitation side of it rather than the vulnerability research side of it. Because they're time constrained, they can't give you an actual real world challenge, because real world software usually takes it takes at least weeks to months to find good vulnerabilities that can be exploited, right? So they usually give you hints that you can use to find the vulnerability and then end up exploiting it. So that's essentially the way I did it. I played CTFs for the better part of a year, I think 8 or 9 months in 2019, until at the end of the day, I decided to move on from CTFs. I still play the harder ones, not the easier ones anymore. But yeah, I sort of moved on. And so after you say you did all of that, right? You play CTFs for a while. What next, right? So what you would do next, I feel, is you would start with a real world target. And this step takes a little bit of effort to figure out, because there's this like a choice paradox like situation, right? There's so many targets. What do you pick? What's the best target to pick? And you won't ever find a good answer for this. You just have to sort of just look at a list of targets and just pick one and just go into it, right? So one way of doing this is to just pick a bug bounty program on any platforms, such as HackerOne, Bugcrowd, Synack. Just pick a random one and just get right into it, right? Don't bother with, is this the perfect program? Is this where I'll find is this the easiest program to find my first vulnerability? And don't ever think of it like that. Just get right into it. Another way to go about it is to just pick a random open source project on GitHub. And since you have code, you can actually read code. And if you've done your practice from CTFs from before, you'll be able to spot bugs in code, because let's face it, everyone has bugs in their code, right? Unless the project has like 300 lines of code. And then, it's 200 lines of code. It's hard to put a bug into that many lines of code. So you essentially want like projects that have at least 1,000 lines of code, hopefully more. So you can actually, so there's like more chances for the programmer to make mistakes. Another thing you can do is just pick an IoT device or an embedded system. So your home router or your television, if it's a smart TV, are like perfect examples. You can try to dump their firmware and then reverse engineer it and read the decompiled code, try to spot any vulnerabilities. And IoT devices are infamous for vulnerabilities. It's very easy to find vulnerabilities in them. And embedded systems especially don't tend to have any security mitigations. So if you do find a vulnerability, it's usually very easy to exploit it. And as I'll get into next, you can earn money doing this if the device you're testing is if it's widely used, sort of. I'll get into that in a little bit. So finally, the last thing you can pick is an actual big target, right? And this is the route I went. I don't suggest this as a route because I've spent a while on my big target, which is Google Chrome. I picked the browser Chrome, specifically the JavaScript engine to start with, and I'll spend a while on it. And it is very, it sort of, you have to have that motivation to keep going, because in your first couple of months, you won't be able to find much. There's a lot to learn. There's a lot of research to do. Yeah, so that's what I did, but I would suggest go start with something easier and build up so you have that motivation to keep on going, right? So say you pick your first target. What do you do next, right? And this is like the stage that takes a lot of time, right? Depending on the size of your project. The first thing you want to do is you want to figure out all existing security research for whatever your target is. And this doesn't apply for open source GitHub projects usually, unless it's like a big project that's open source. So yeah, you want to just use Google. You want to find all existing research, learn about the internals of whatever you're trying to do research into. And I apologize again, because like I said, I specialize in low-level vulnerability research. So this might sound a bit biased towards the low-level side of things, as opposed to like the high-level web application bug bounty like side of things. So yeah, it might sound biased, but it can't be helped, right? So anyway, so yeah, you just read all existing research, right? And this also applies to web applications in general. If you're testing something like, say, you're testing Facebook or Google or Twitter for vulnerabilities, you want to read or study past vulnerabilities as best as you can. And you can find these vulnerability reports on places like HackerOne or Bugcrowd. I forget where Facebook and Twitter host their bug bounty programs. But yeah, you essentially want to study these past vulnerabilities, because chances are wherever those vulnerabilities were found, more exist, right? Because vulnerabilities always exist in the most complex parts of software, right? So as an example, right? Say you decide, I'm going to go back to the low-level side of things. Say you decide, you want to target kernels, right? So you pick the Linux kernel and you want to study a vulnerability, right? Usually at the beginning, you choose reports that are very detailed, that explain exactly what the vulnerability is, what the root cause is, how you would exploit it. So it has all the details, and you use reports like this to really push your knowledge to the limit that you can get to before being able to analyze the vulnerabilities yourself, right? And once you get to that stage, what you want to do is you want to pick reports that are less detailed, right? So they just say, for example, they give you a proof of concept that causes a crash. That's it. Once you have the knowledge from the previous reports, you'll be able to take that proof of concept, go through the code, trace the code to see exactly why it's crashing, root cause the vulnerability. And while you do the root causing, you'll be reading like hundreds and hundreds of lines of code every single day. And when you read all of that code, you will be able to come across other vulnerabilities if they exist, right? So you'll just be reading one function, for example, code for one function A, and you'll see some code, and you'll go, this is making an assumption that function B from before made this other assumption, right? And you just go, okay, this doesn't make any sense. Let's see if this is an actual vulnerability. And that's how, when studying past vulnerabilities, you sort of move into finding your own vulnerabilities. And that's why the next step is just profit, right? The way you go about it is to just analyze past vulnerabilities in order to find new vulnerabilities, right? Because like I said, wherever past vulnerabilities existed is where new vulnerabilities exist, usually, right? Unless it's something new, like completely new. Like, for example, if I remember correctly, Windows Defender was getting ported over to Linux. I believe I heard this sometime last year. I don't know if that's still a thing or if it's happening, but assuming it does get ported to Linux, you can look at the past vulnerabilities that existed on Windows for Windows Defender and just go move over to Linux and look for the same vulnerabilities and try to see if porting over the code introduced any regressions, which is like introduced any of the past vulnerabilities or any new vulnerabilities, right? So unless you have some completely new like software that has no previous research, you would just go for past vulnerabilities and move into the current like state of the software and hopefully find new vulnerabilities, right? So that is essentially how that works. Now, the profit part of it, right? So this is where this money involved thing comes in. How do you earn money while doing this, right? And the first way is to get a professional, like a job, right? That helps you, that lets you do research, right? And one very important job, I guess, is security engineer. So this would include you being part of a development team of an organization. So I'll just use Google for an example. If you were part of their Chromium development team, you can be a security engineer in their development team. And what that would mean is you just do code review of any patches that they create for their browsers, or just not browsers, browser singular, Chrome, and you would attempt to write new fuzzers to find new vulnerabilities in their browser before it gets pushed into like the public space. So their customers or users around the world wouldn't get affected. So that's a security engineer role. There are lots of these all over the world. I believe Atlassian has them, Google has them, Microsoft has them. It's just everywhere, right? So that's one possible role. Another is just security researcher. And this is a role that's more rare, and it's especially rare in Australia. But if you look around the world, you can find roles like this in places like Google's Project Zero team. You can also find researcher roles in Trend Micro's Zero Day Initiative team, Theory.io, which is an American/Korean company, Tencent's research labs in China as well. Finally, there's probably Exodus Intel, which is a US-based research company. They handle 0 days and 1 days, etc. So this role is very rare, but if you do find, or if you are able to get a job in this role, it's pretty fun. It's really cool. You get to spend your time finding vulnerabilities in software 24/7. And if you enjoy that sort of thing, it's really cool, right? And finally, the last possible professional role that I can think of is a security consultant. And this is a broad category, I guess, of like consultancy is really broad. But what I mean here is specialized roles, right? So for example, I can use the example of Stephen Seeley. I don't know how many people here might have heard about him. He's an Australian security consultant, and he's an independent security consultant. So essentially, he does consultancy where he does code review and reverse engineering of software, and he gets hired as a consultant to do that sort of thing. And I believe he's done gigs with Adobe and Docker and organizations like those. He's found lots of vulnerabilities, and this is the same thing as doing research, except you're getting hired by the company to do it internally on their code, which wouldn't be accessible from the outside. So yeah, so those are possibly the 3 different roles that I can think of. Now, these are professional roles, right? You're stuck in a job. So for those of you who would want to work for yourselves, there are multiple ways to go about it. The biggest and most common way would be bug bounty programs, right? So these are on platforms such as Synack, HackerOne, Bugcrowd, and these essentially let organizations host their own programs or host their own bug bounty programs on these platforms. So instead of having to go to 100 different websites for 100 different organizations to find all of their programs, you go to one of these platforms and you'll find 100 different programs from 100 different organizations, right? And these organizations essentially give you a scope, and they tell you you can test these endpoints, you can find vulnerabilities here, and you can report them, and you will get paid, right? And the bounties from these programs can vary a lot. So it can go anywhere from like $100 to $10,000 plus, depending on how big the program or the organization is that you're testing their application. So another thing about bug bounty programs is that they generally focus a lot on high-level vulnerabilities. So by high level, I mean sort of web application style vulnerabilities. So like cross-site scripting, server-side request forgery, things of that nature. And this isn't true for all of the cases, right? It's in general. There are some bug bounty programs, such as the open source software bug bounty program on Bugcrowd, I believe. It essentially has software such as Apache, PHP, and you can test their, these are low-level programs, right? So you can try to attack Apache, the web server, directly instead of a web application that runs on Apache. So again, in general, bug bounty programs focus on high-level vulnerabilities, such as in web applications or mobile applications, things of that nature. I just went on Bugcrowd today and took that screenshot of a random online banking applications program called Simple. As you can see, it goes from anywhere between $100 to $3,000 plus per vulnerability, depending on its impact, is what I assume. I didn't really read into it that much. But yeah, usually they give you a rough estimate of what sort of vulnerabilities they'll pay what amount of money for. So you can work based off of that. The next thing I move on to is vulnerability rewards programs. Now, these are similar to bug bounty programs, except they're on their own sort of platform. And because these programs essentially let you test huge like very widely used, very well-known software, and this can include things like Windows, the operating system, Chrome, the browser, Firefox, the browser, things of that nature, right? And because of this, they mostly focus on low-level vulnerabilities. Low-level meaning vulnerabilities such as buffer overflows, integer overflows, use after freeze, things of that nature, bugs you find in C and C++ programs. On the other side of things, because this type of software is very complex, they actually have their own sort of bug classes that you have to learn about when testing or trying to do vulnerability research for this type of software. So just as an example, browsers, for example, JavaScript engines have a garbage collector built in C++, right? Now, C++ is not a garbage collected language. Therefore, the garbage collector can introduce race conditions within the JavaScript engine itself. And this is its own bug class, right? You won't find this sort of bug in like operating systems, for example, because operating systems are not garbage collected. So it's like very specific towards JavaScript engines. And it's sort of, that's what I mean by like program specific bug classes. You actually have to spend a lot of time studying the internals of a program to be able to find vulnerabilities in software like this. So yeah, they have their own platforms. So an example is the Chromium vulnerability reverse program from Google. That's the amount you can get from them. There's also the Microsoft Security Response Center bug bounty program. That again, amounts of money. Mozilla VRP, Apple VRP. There's also another one, Trend Micro Zero-Day Initiative program. And this one especially, it's very generic. You can find vulnerabilities in any piece of hardware or software. And as long as it affects a lot of people, like worldwide, say millions of people, right? So it has to have a large impact. And if it does, Trend Micro is going to pay you for the vulnerability, and they're going to use this to improve their own systems or their own tools that they develop, because Trend Micro develops like defensive security tools, as far as I'm aware, like firewalls and intrusion detection systems and things of that nature. And yeah, there are a lot more. You have to just Google and like try to find places that will pay you for vulnerabilities, and yeah, you can get paid, right? So another way to earn money, I guess, is through exploit shops. And these essentially, if you find a vulnerability, you can't just sell the vulnerability to them. You have to write full chain exploits that can compromise like machines, like from zero to like just compromise, I guess. And full chain meaning multiple exploits. So nowadays, with all the security mitigations that exist in software, generally one vulnerability isn't enough to compromise a machine. You need multiple, so at least two, usually 2 to 3. So yeah, you need to write these full chain exploits to sell them. And these are very time consuming, hence these exploit shops pay the most amount of money. Two examples that I can immediately think of are Zerodium and Exodus Intel's research sponsorship program. So these guys use your vulnerability for their zero-day research news feed. So they essentially have clients that subscribe to their news feed of 0 days. And the clients are organizations around the world, I believe governments as well. So when these guys buy your exploits, they let their clients know, hey, there's a 0-day exploit out for this piece of software. Patch your machines or fix or disable whatever is like vulnerable. And so their clients know to do that. And these guys, this is what they use your 0-day exploits for. As I said, they usually pay a lot more than any VRP. The only disadvantage being that they require full chain exploits, because these exploits require a lot of time to actually write and be stable. Stable exploits are very hard to write. So yeah, but yeah, these places pay a lot of money. And I'll just use Zerodium as an example. If you look up top, it pays up to $1 million for a Windows zero-click RCE. This is very hard to find a vulnerability like this, but it does happen. And when it does, as you can see, Zerodium pays a lot of money for it. So yeah, you can find this diagram on Zerodium's website if you want to. Yeah, so the last thing I want to cover are competitions. So competitions such as, I'll go forward a little bit. So yeah, competitions such as Tianfu Cup, Pwn to Own, Typhoon Pwn, there are a couple others, but essentially researchers go to these competitions and they attempt to showcase their exploits on stage out in public. The competition organizers generally pay for these exploits unless the vendors themselves are on site, and then the vendors themselves, I believe, can also choose to buy or pay the researchers for their exploits to be able to patch them later on. So yeah, Pwn to Own, for example, is hosted by Trend Micro, who runs the Zero Day Initiative program. So in the same way, they probably pay the researchers to get their exploits at the competitions and improve their defensive tools in however way they can. Yeah, so yeah, we've covered like what bug bounty programs, vulnerability rewards programs, exploit shops, and finally competitions. And yeah, so these are the ways you can work for yourselves and earn like the money if you really choose to. Yeah, so I guess I'm 5 seconds away from 30 minutes. So yeah, so that's pretty much the talk. If you have any questions, I'll be able to answer them on the Slack. Yeah, so that's pretty much it. Thanks, guys. Hope you enjoyed it. And yeah.